Now we will go to the last few groups, like group 4. Over here we get nickel sulfide, cadmium sulfide, manganese sulfide and zinc sulfide. Nickel sulfide is black, remember, cadmium sulfide yellow, manganese sulfide little different color, buff colored, and zinc sulfide is again colorless. All the white, all the precipitation, zinc sulfide is white basically, or colorless you can say, and all the precipitation will be treated one by one. First we will treat with concentrated HCl. If we treat with concentrated HCl, what happens is that the zinc and magnesium, zinc plus 2 and magnesium plus 2 will dissolve as zinc chloride and manganese chloride. But nickel sulfide and cadmium sulfide will fail to dissolve. Where they will dissolve then? The only one media is aqua, which is very tough precipitation. You know, they cannot dissolve in any kind of acid, HCl, H2, so H3, even water or something like that. But it only dissolves in aqua regia. That means what? Now come to first the concentrated HCl dissolved part, zinc chloride MnCl2. In case of zinc chloride, if you use potassium ferrocyanide K4 FeCN6, we get K2ZnC FeCN6 twice, white precipitation. If we take zinc chloride solution in NaOH, we get Na2 sodium zinc. It is the dissolved part, dissolution in sodium hydroxide. And then if we take H2S, once again if we pass zinc sulfide, again white precipitation will come up. So confirms zinc plus 2 is present, zinc plus 2 present, zinc plus 2 present. Now if we talk about manganese, how to prepare manganese, how to detect manganese plus 2, rather manganese plus 2. You know, manganese plus 2 has to convert to MnO4 minus, where we can get pink coloration. How is it possible? Just oxidize Mn plus 2 going to Mn plus 7. In between it will go to Mn plus 4. So how it is possible? Br2 NaOH, bromine and NaOH solution if you add, that means OBr minus you are adding, where bromine is plus 1, so obviously it is oxidizing. So this bromine plus 1 basically will convert Mn plus 2 to MnO2. Now this MnO2 is further treated with HNO3 and PbO2 or PbCO4, red lead, Pb3O4, or it can be PbO2 or Pb3O4. If we use, then we can get permanganic acid HMO4 plus PbNO3 twice plus H2O. That is, permanganic acid is pink in color, that is HMNO4, confirms that manganese plus 2 present. Manganese plus 2 present. After this operation, we can see that manganese plus 2 present. Now we'll come to other part, nickel sulfide and cadmium sulfide. Both the precipitates are basically, nickel sulfide is basically, you know, the black, and cadmium sulfide is yellow. I'm sorry, it is cobalt sulfide, not the cadmium sulfide. I'm sorry, so sorry, cobalt sulfide. Cobalt, because we have already did cadmium in group 2A analysis. We have got cadmium plus 2 already. This is cobalt sulfide. This is cobalt sulfide. Now, cobalt sulfide is again black. It is black. Cobalt sulfide is black. So this nickel sulfide and cobalt sulfide will be treated with aqua regia, that is HCl plus HNO3. So you'll get nickel chloride plus plus sulfur colloidal suspension of white color and H2O. So you get nickel chloride solution. So see, just this, the precipitations were not dissolving in any kind of individual acids or water or hot water, only dissolves in aqua regia. The reaction will be the NiS plus HCl plus HNO3 will give you 1 HNO 3 HCl. Ratio will be the aqua regia will get NiCl2. Also you will get cobalt chloride along with the gas coming out and sulfur colloidal suspension. These sulfurs can be again treated with the concentrated nitric acid, make the sulfate solution, which is colorless basically, it happens. Now nickel chloride, once treated with ammonium hydroxide and DMG. First what we do is that this solution, first water is evaporated out and dried residue we get, and then dried residue is treated with NH4OH DMG, dimethyl glyoxime. We get red precipitation. Red precipitation is just like this. This is the red precipitation. There is this dimethyl glyoxime nickel 0. Over here nickel 2. Nickel 2, it is over nickel 2. Everybody knows there is nickel plus 2 basically. Nickel 2. So this is a complex we get basically where hydrogen bonding takes place between this OH and this oxygen. You can look at the board. So therefore this complex is red colored complex. So with the help of that we can get that, we can say that nickel plus 2 confirmed. We say nickel plus 2 confirmed. And for the cobalt plus 2 we go for KNO2 plus acetic acid mixture. It becomes CuNO2 twice, cobalt plus 2, still not cobalt plus 2, but cobalt plus 2 over here, and then further HNO2 addition gives you oxidized condition CuNO2 thrice. The HNO2 is acting as an oxidizing agent, go cobalt plus 3, and then it makes complex K3Cu2 that is called potassium cobalt nitride, and this is called yellow. There's basically yellow color precipitation we will get, yellow color compound we get, confirms that cobalt plus 2, confirms cobalt plus 2 present. So therefore confirms cobalt plus 2 present. Now come to, after group 4 we come to group 5, where what are the compounds basically there waiting for us, which are the cations, is barium plus 2, calcium plus 2, and strontium plus 2. Both precipitates out. In the initial case I said that it is basically carbonate precipitation, ammonium chloride, ammonium carbonate, they all give carbonate precipitation, and all basically carbonate dissolves in acetic acid. If you take acetic acid, they all dissolve, and after the dissolution, the solution is now treated with different reagents. Let's say potassium chromate, if you add, we get barium chromate yellow precipitation. If you give ammonium sulfate, we get strontium sulfate white precipitation. If you go for ammonium carbonate, we get calcium carbonate white precipitation. Their conformity test can be done through flame test, like barium plus 2 shows apple green, and the calcium plus 2 shows brick red, and strontium basically crimson red. So we have already discussed in the flame test, so that way also you can confirm the metals over here in the group 4 basically. And before actually group 5 basically, before we have already decided that by the flame test whether these particular 3 elements are 3 cations represents or not. Now we'll come to group 6. Next group is group 6, that is reduction of magnesium plus 2. If we add disodium hydrogen phosphate, ammonium hydroxide, you get white precipitation of MgNH4PO4. This is basically white, and which basically confirms after all groups that magnesium plus 2 is present, magnesium plus 2 is confirmed. Now if I talk about group 6, group 6 contains, we can say sodium plus, lithium plus, ammonium plus. Most important to us in our curriculum is ammonium ion. Ammonium ion, if you distribute with NaOH, of course ammonia gas will evolve, and if we take a glass shot dipped in HCl over the mouth of the ammonia coming from test tube, is basically we get ammonium chloride white fumes. And also ammonium ion, if we distribute with Nessler's reagent, K2HGI, for it's called Nessler's reagent, plus KOH, we get NH2HGO-HGI, that is called iodide of Milan's base. Structure is like this: NH2HGO-HGI, iodide of Milan's base, plus Ki plus HCl plus H2O. So with the help of that, we can prove that ammonium confirmed, ammonium present. We can say ammonium confirmed. So therefore you remember that these are very, very important to us, these tests, as a basic radicals, and we'll discuss more vividly right now on the several other reactions on these particular cations. This is the basic way, the basic technique we adopt in the practical analysis of the basic radicals. So my dear friends, now we'll discuss vividly some more chemical reactions of the group 1, group 2A, group 2B, etc. metals. For example, if I talk about group 1 metals over here in the qualitative analysis, not the periodic table, group 1 I am talking about, is silver, lead, and mercury 2 plus 2. We will discuss one by one. For example, the characteristics of group 1 metals are all nitrates are soluble, and all lead sulfate is insoluble, silver sulfate dissolves to a little extent, and very less mercury sulfate dissolve. Next, PbCl2 hot water soluble. Bromides and iodides are insoluble. Sulfides are insoluble. All group 1 sulfides are insoluble. Acetates are soluble, excepting acetate, silver acetate is insoluble, and all hydroxides and carbonates salts are insoluble or precipitates out. So I'll take some reactions of the lead first. Lead is basically bluish gray in appearance, and lead plus 2 can react this way. Just go on. With chlorine minus, it can give lead chloride, white precipitation in cold water, and concentrated HCl if we add, we get PbCl4 minus 2 complex, which is soluble. Next, if you talk about H2S plus high concentration HCl, concentrated HCl, we get basically Pb2SCl2. That is Pb2SCl2, it is a red colored product, and this Pb2SCl2 in presence of H2S decomposes to PbS and is black precipitation. On dilution you get basically PbS, again black precipitation. This PbS, if it distribute to H2O2, we get lead sulfate white precipitation. Now come to other reaction. Let's say lead sulfide, I am taking the initial material. Now lead sulfide concentrated HNO3 can give you lead plus 2 nitrate NOSH2. This is in presence of concentrated nitric acid gives you sulfate. And this sulfate, if we treat it with Pb plus 2, we get PbS for white precipitation. Now This Pb plus 2, if it is treated with OH minus, that is NaOH, we get PbOH2 white precipitation. If you give excess NaOH, we get soluble PbOH4 minus 2 complex. It is soluble. Now if we treat this Pb, basically this is plus 2. If we treat this H2O2, we get PbO2 black precipitation. Other series of reaction, Pb plus 2 in presence of carbonate gives you PbCO3 white, and if it is heated, Pb plus 2 H2O plus CO2 evolution takes place. So lead carbonate on thermal decomposition produces carbon dioxide. Next, Pb plus 2 plus sulfate gives a Pb sulfate, lead sulfate white precipitation. In presence of sulfate, it produces PbHSO4 twice, which is soluble. So it should be remembered, lead sulfate basically dissolves in concentrated sulfuric acid hot, produces PbHSO4 twice, just like bicarbonate, calcium, magnesium, etc. Now with acetate, it forms a soluble complex PbOCOCH4, lead tetraacetate. Basically over here, Pb is plus 2. Now if you go for further reaction of lead plus 2, over here you can check lead plus 2 with potassium chromate gives you lead chromate. Lead chromate is yellow in color. Now lead chromate in presence of H plus gives you lead plus 2 and dichromate, because dichromate exists in the acidic medium. If you take this lead chromate in basic medium, you will get CrO4 minus 2, it is also yellow precipitation. It is orange, dichromate is orange, chromate is yellow. Chromate and dichromate, basically if you see chromate and dichromate, CrO4 minus 2 exists in the basically basic medium, and in acidic medium basically we know dichromate exists. So the same thing happens over here. With when lead chromate is treated with acid, we get dichromate and lead plus 2. When we treat it with base, we get basically in basic condition we get PbOH4 minus 2 and chromate basically comes out. This is a yellow color. Now same lead plus 2, if it is treated with I minus, you get PbI2 yellow precipitation, and PbI2 with excess I minus also gives soluble complex. That is lead tetraiodo plumbate. Tetraiodo. This name of this complex will be tetraiodo or tetraiodo. Tetraiodo plumbate. It is, of course, it is plus 2 state, so it is plus 2, so obviously 2 this complex will get. Tetraiodo plumbate 2 complex will get. So these are the reactions of the very important reaction of lead plus 2.